one of these today. And so, if you remember last year, I introduced the Solid Edge for Startups program. We announced we'd roll it out starting in the US and the UK. And the past year, we've already screened and brought in 125 companies into this program. And these are small startups that meet some very specific criteria, but in our eyes have a chance to be the next big Dyson. So what do we want to do? We want to help them get the right access to the right technology, start right away in the Siemens portfolio, and be a customer for life. But that's not enough. We're now going to roll it out to another 31 countries this year, because this has been great. We have met a lot of great companies, and if we can get 125 great startups in just 2 countries, I can't wait to come tell you what we're going to do next year. So, the last couple of days, you've heard a lot about digital twins. And everybody wants to hear the word digital twin one more time? Probably. No, you're good. So I'll fix that for you. What I'm going to do is introduce you to some physical twins. So we're going old school all of a sudden. We have with us today RadioBro Corporation. Now, unfortunately, I thought about this. They might be digital twins because they're identical twins. But nonetheless, they just joined our starter program a few months ago. But I thought it would be fun to actually hear from one of these, because as Bob brought up the example of Dyson, there's a certain energy and a feeling you get when you talk and work with these startups. You can see they've got different needs, the way they use software, the way they buy software, the way they're trying to grow a company. And frankly, it's absolutely invigorating to work with them. So they recently joined our program. I'd like to introduce you to Mark and Eric Becknell of RadioBro Corporation. They're out of the Huntsville, Alabama area. And I'll let them tell you what they do.
Thank you. My name is Mark Becknell, and a little bit about the interaction. I forgot to mention this over the last couple of days. We're actually across the street from where Solid Edge is written. And sometimes you guys actually come knocking on our door to say, hey, what are y'all doing cool today? Which is nice. So your software developers are fantastic, and also professional friends here. I'm the president, and with my brothers, we're the owners of RadioBro. We're a small business in Huntsville, Alabama. It's a traditional aerospace community. So usually people are serving either going to space or airplanes and helicopters. That's most of the mainstay of Huntsville, Alabama. But with my brother and I and a few other peers at our university, we actually got a heavy start doing innovative development as students at our local university in Huntsville, University of Alabama in Huntsville. And through our master's studies, my brother and I, we built with our peers a small spacecraft, went to orbit. That was kind of special because a non-government sponsored group just ad hoc in the after hours built a spacecraft. 3 years later, we're in orbit, having qualified on fundraising, all the logistics. And after we graduated and finished that opportunity, we diverted our energy and we founded RadioBro. We found a huge need in our community to build innovative electronics to solve serious problems. Funny enough, it's almost impossible to buy, at least at that point, the components to build a spaceship. All right, where do you find it? Well, now there's web stores all over the place, built in hundreds of teams are providing those through e-commerce sites, and we happen to be one of those, and we're excited to be part of that market. So, RadioBro, we're in Huntsville. We didn't take this picture, but I think this was off the space station. We could take this picture. We like doing weatherability. We are designing innovative electronics. We're designing them very quickly. My brother's got a couple in his hand. Here, the products we're building are about the size of cell phones. Our product life cycle is on the order of 4 to 6 weeks from first text message from a customer saying, hey, can I have this please, to first article coming off an assembly line. And that includes all the design of mechanical, electrical, and software, as well as coordinating with about 5 different supply companies that execute our work. Whether that's metal cutting, connector production, circuit manufacturing, the assembly processes, the box build, and the testing. So it's quite an intense team that we're pulling. But we actually leverage Solid Edge to do most of our design control and production control of our product. So we work in the digital world. We're building with a digital twin the entire time, right? So I have to deal with my biological twin here. However, our products are built with a digital twin the entire time. But the first time we see a product come off the line, we've already seen it plenty of times because we've lived it in the digital world. It has interesting holes as well in our workforce. Most of our team is is relatively new at their work. We do have a few people that are older than us in our company, but there's a lot of young workforce. That isn't necessarily an accident. We're very fast moving. So as soon as a new software package is released, I need to get somebody on it that's been trained. And we'll talk a little bit about how your options have enabled us to do the work we're doing in Industry 4.0 on airplane and spacecraft.
So at RadioBro, our first product and I guess our initial business plan was around serving the small satellite market and providing and selling commercial off-the-shelf products. Our first product was Mini Satcom. It's a small transceiver that allows you to text message a spacecraft. And it's this big because every gram matters when you're paying for it to go to orbit. So when we developed this product, we developed our entire product realization process. That's our entire design and production and testing process for electrical, mechanical, and software. And we really got our stuff together, but it turns out this is a very small and growing market. It's important, but Huntsville had a bigger problem. So they came to us and said, can you please provide us a new solution for aviation and flight test? So what we did is we transitioned our company pretty quickly, because it's a small company, we're going to look for money. And we designed and built the next generation flight test instrumentation system. This is serving for aviation, helicopter, fixed wing flight test, and it can easily be used for drones, but it really leverages the same methodologies we've already perfected using our spacecraft methods. This is a mock-up of our product that's currently in production. We'll be flying in a few weeks with our customers during their certification process of their aircraft. What makes our technology special? It was designed against the real-world problems that our customers were seeing. So our approach was listen to the customers, listen to all their gripes and complaints and all of their dreams, and we engineered a solution around that. And we really came up with something very competitive.
And test pilots are incredibly passionate about telling you what they don't like.
Yes.
You have any pilot friends that are test pilots?
Their job is to tell you what's not quite right. So we listened, we absorbed. We are very aware of the state of the art, and we invented a system that is self-learning. It's based on plug-and-play sensor technologies. It's a network expandable system, but it still leverages the traditional mil-spec approach to interfaces, enclosures, and ruggedization that allows us to have a successfully operating system in a horrible environment, which is exactly where you want your equipment tested, because that's the endpoint. In fact, this is so revolutionary in this particular industry, they're going to get access to test points they've never had before, because our system is small and can handle the environment they actually want to do testing in. Our system, by the way, syncs to the cloud. It can pump its data up. It can get software updates from the cloud. And it also has a web user interface that you see here in the bottom right corner. The reason for that is because in every airplane, there's no real estate in the cockpit. It's all already occupied by the aircraft OEM. They designed every square inch. So where do you put a user interface during flight test? And the answer is on the iPad, for example. The significance of that is almost every pilot now flies with an iPad for their maps and their up-to-date information as an accessory. So now we use that interface to expose them to the real-time information that's being collected across the aircraft. The significance of our plug-and-play technology is that it allows for a few things. Their ability to understand and design the instrumentation system is faster. Their ability to purchase off of our e-commerce site is immediate. No longer is it a 12-week lead time. And finally, on site, when it's time to actually plug stuff together, our stuff is self-learning, which means that you don't have to have a specialist come and help you wire it, configure it, and plug it in and make it work together. It truly is. Any of our customers, regardless of language barrier or anything along these lines, can install our system successfully. What you'll see here on the plot on the top is a timeline. We can save over 10 weeks in a flight test instrumentation process. That's significant. That's all the engineers, that's the entire program. If you can save 10 weeks on a program, that's 10 weeks sooner your product gets to market. So that's why we think that our technology is going to be extremely disruptive. Additionally, if you save 10 weeks, that accounts for about 40% of the timeline, therefore about 40% of the budget directly associated with testing. So here's a huge marketplace. Every single aircraft, every single modified aircraft has to go through this process as they try to qualify their system, and we're trying to help them get their product to market sooner, and there is room for disruption. And RadioBro uses this method in several industries, and this is certainly our biggest one.
Yep. We are a small company, there's 10 of us, and so most of my team are engineers. We outsource our legal, to our community. Our community can do lots of different types of business operations, so we have an accounting firm, we have a legal firm, we have contract manufacturing. We actually founded our company inside of an electronics assembly house. So they accidentally told us how small their robots could place chips, and my brother took that as a challenge. So the products are designed to the absolute smallest chips their robot can handle, and that's why we have really small products. It also means that we're designing for manufacturability. So let's talk about how the software packages help solve our problems to meet those timelines. In our world, as discussed in the last few presentations, we are completely married between our mechanical modeling and our circuit modeling, 100% married. That's our job. We're building black box solutions. They're embedded systems, they have structures, they have thermal, they have environmental requirements, but they have chips. And the chips have different properties, whether they're thermal properties or electrical properties, insulation issues, whether it's a high voltage or some transient control. So take a look at the flow behind me. This is a workflow for our every day. Every day we're moving from the circuit board to the mechanical back to the circuit board, and we'll release the 2D drawings. We'll release 3D interface control so that they can go ahead and 3D print at the airplane factory and start positioning it by hand. If they're calling us for something really fast, it's probably because they need it really fast. So we have to start practicing integration with 3D models. So we're familiar with your changes inside of Siemens. We're excited about getting access to tools like Mentor and how we can integrate that into processes like ours. We've made available